All right, so this one we're going to go over setting up just a generic COM app, which is what I was able to do last week as well. So this is where you're going to have to decide what's easier for you. But I've got a generic COM app turned on in app slot 31. I'm going to call this a, we could do this one as liquid or gas, but I'm just going to call this serial. Coriolis for now. Okay, we're going down the line here. COM, I'm going to call this COM1, which apologize, I got to go turn off this other Coriolis app so that I can actually work with this. All right, so we're going to turn this to none, send it. Come here, we're going to set this as COM1. Okay, notice how it stays after I reread. Okay, protocol, we're going to do this as Modbus RTU. If you are doing a TCP version, just do Modbus TCP client. Okay, but since we're doing serial, we're going to do Modbus host. I'm going to leave that as onboard serial. When you turn that to Modbus TCP, it's going to automatically just send it, and it'll get rid of a lot of this other stuff that's down here. Okay, so don't waste your time. Now, if you're going to the micromotion, it has to be at 9600 baud rate. If you go to on the gas meters, it only has the core. If you go to the 5700 head, which is TCP, or the ABB Coriolis meters, we just need to match all these. And I prefer 19.2 baud just because we get a little bit, faster comms that way. But the micromotions that are on the gas side, I believe, are 9600 only. Okay, you need to make sure that the interface is set to RS45. 8, none, and 1 is pretty standard. The ABB meters, this might be set to odd, just FYI, unless you get into the meter and you switch that, but they default at odd, I believe. Okay, I'm going to send that. Hopefully I didn't just lose comms to my board. All right, there we go. Okay. Everything is updated. All right, so if I'm going to the micromotions, it's going to be Modicon. If I'm going to the ABBs, it's going to be word swap. You can fix this in either meter. You just need to change the base 0, okay? Or turn IEEE off. If you turn IEEE off in the ABB meters, it sets it to Modicon. If you turn IEEE off or set it to a base 1 offset, it's going to be word swap. Same as for the micromotion, okay? So let's pretend we're going in the micromotion. Well, I've got to do it this way. Sorry. And I do believe that this is 19.2 baud for the meter I'm going to try to get into. Okay, I'm going to go to advanced. Okay, 8, none, and 1. I typically like to set these at least a non-zero, so I usually do 5, 5, and 5, or 10, 10, and 10 kind of thing. All right, and trailing pad, again, I'm going to set this at, let's say 3 bytes. All right, and I'm going to send that information. All right, now we go to the request blocks. Okay, so you can build these up one at a time by simply coming to add. Let's say this is mass flow, okay, or mass FR, however you want to do it. All right, so I know by default, unless you don't have the Emerson Modbus map, I can send that to you if you need. Okay, I do believe that we should just be able to leave it as a read register. All right, slave ID is 1. All right, I do know that it's 249 for the Modbus. Okay, that is in our meter as well as the micromotion. There might be 247. Might be 247. Let's do a quick test real quick. 247, my bad. All right, go back up to here. We have to reread this and send it off. So it's that again. Mass FR. Okay. Slave ID is 1. We're going to send this at 247. Right. We're going to just do one register. Okay, you can do multiple registers if you want. So, typically these are 16-bit, so you at least have to do 247 as the data you wanted in, and then the next register would be 0.0.0, and then 249, and then 0.0.0. All right, so you'd have to do your destination register as holding register 0.0.0, holding register 0.0.0, holding register 0.0.0. So you got to space them out like that because they're 16-bit registers. Okay, we're just going to do one at a time just for the sake of this. And this one I would highly recommend turning on. All right, this is going to tell you what your response status is. So if it's a 0, it's good comms. If it's 1, it's legal data address. I think that means that the register we're trying to request is not there. I think number 2 is invalid function. Anyways, I'll try to find that and show you, but it's a very good troubleshooting tool. So we're going to send this up since it's an app slot 31. We're going to do 31.100.0, right, just for the sake of what we're doing here.
All right, we come to here. I want this data point to go to 31.100.100.1. Too many dots. All right, there's all that. I'm going to send it. Okay, I still need to set up my holding register, so I'm going to turn on 20. You don't have to, I'm just doing it. All right, go to holding registers. All right, now I need to give it, let's say I want to put 20 registers here. I want them as floats. I would suggest putting them as indirects. Give it a name. Let's say this is Coriolis flow data. And it works if you spell it right. I'm going to send that. Okay. So now if I come down to holding registers, all right, for the first time, you can see here's my response status. So core-1, let's say response status. All right, this one would be mass flow rate. Okay. Then I can just kind of consecutively put the rest of them that I want down here. Okay. All right, so you can see here, I am not talking. I'm not talking at all. So why is that? Okay. So this is where we're going to start troubleshooting. Okay. 19.2, 8.9.1. This is the setup I got. So if I'm not talking to it, I've got other issues going on. All right. Column 1, onboard serial, 19. Modbus host RTU, 16-bit word swap. Okay. All that looks right. We're 8, none, and 1, 555. Okay. So something it does not like. I do believe the slave ID is right. Let's make sure. So if I go here, go to advanced. All right, so Modbus ID is that. It's active. Okay. All right, so I'm not talking, but I'm going to figure that out now. 247. Okay. Now, anyways, so you'll have to go build on the next one. You can do add or come here do a send as. Call this one say volume, volume FR if you want to, kind of thing. It resends that same exact data, so you just got to come over here and change that to the right register, which I think is 253. Okay. Update this to up at 1. We can leave that response status there. We can add a new response register. Since we've already got one we're talking to, we can just send the rest of these as 0. Okay. So I'll come down here. Since I'm not talking to it, I've got other issues going on, but you can see here. So now this next one will be volume flow. Okay. All right, so on and so forth. So that's kind of how you start building up your Modbus map and your template. Okay. The other way to do it is you can come down here to add, go to browse, and I will try to send you a file that will have this in it. Okay, you see all these? So these are pre-built MRBs that you can load. All right, so here's oil density, here's oil flow rate, oil volume. All right, these are set up for doing volumetric, but it should be the same. So kind of the same thing here. So I hit OK, push to send it now. All right, so you see here's my MRB. So I need to update the slave ID. All right, there's that, there's that, there's that. I need to update this 31.100.2, or sorry, .3. All right, I'm going to change that to 01 and send. Okay. So this is how you build it up. So you got to build these very manual like this and just kind of go through that. So the Modbus mapping is located, so you can go online and look for it. I will share what I have here, okay, and send it along with you on that. All right. So anyways, so that's how you set that up there. So once you set that up and you get your holding registers, that's like this volume flow rate, okay, 31.100.0. I'm now going to go to facility measurement, my AGA, or wherever this AGA-7 is, okay. go ahead and finish setting up all your data here like we did in the previous section. Okay, come to advanced setup. You can do it as accumulator, again, or flow rate. Put in your register down here. Good to go. But the one thing I need to check on is this volume flow rate. So essentially, this is how you go about setting it up. But I would recommend doing the accumulator, so that way we don't miss any measurement, and we pull directly from whatever the end device is that we're talking to, and then you're good to go on that. So that is basically kind of a short, in a nutshell, kind of how you go about doing that. Again, you're going to have some data packets here. So this will have a packet log, which the Coriolis interface does not. So if you turn it on, right, you can see your back and forth. All right, so I'm not seeing that Coriolis at all anymore. Right, I got one-way traffic. So here's my first Coriolis. Here's my Modbus function code that I'm using. Then here's the data that I'm requesting. I don't have a back and forth arrow here. Okay, my errors are just compiling. Right, but essentially that's it in a nutshell. I will try to send you one more version of the gas Coriolis interface app, where it's basically the two apps that I just went through combined into a single app. I don't know that much about it, so I got to get some education on it. But anyways, hope this helps.